Hi, everyone. Good afternoon, good evening, good morning. I'm in Washington, D.C., so it's afternoon here. So today is an informal chat with two members of our engineering team, Joel and Jordan, and I'll let them introduce themselves in a bit. We thought it would be fun to have a conversation about what it's like to be a database engineer at Cockroach Labs, working both on the core CockroachDB product, as well as being a site reliability engineer on our Cockroach Cloud product, which is our SaaS offering, our database as a service offering. Some context before we get started, our Cockroach Cloud product is still relatively new. Our self-service product was launched as a beta last year, end of last year, and we're working towards a general availability a little bit later this summer. And our cloud team started with 2 people a couple of years ago now, and now we have a full-fledged team of front-end engineers, site reliability engineers, full-stack engineers, product designers, documentation writers, product managers, kind of the whole spectrum of different functional areas. And then we also have sub-teams of core database engineers who work on CockroachDB, and Jordan will speak a little bit about that in a bit. So the format of this webinar is really quite informal. We want to keep it as a conversation. I have a set of topics and kind of questions, leading questions that I have that I'm interested in hearing a little bit about from our panelists, but we also want to see where the questions we get are on the chat and the Q&A. So please feel free to kind of converse and ask us questions on the Q&A, and we'll see what topics are more interesting to you all. And yeah, like the overall goal of this panel is just to get a little bit of a better understanding of the roles of our SRE and software engineers at Cockroach Labs, and some best practices and all the ways in which we are constantly learning and working to improve our offerings. When Jordan and I were chatting earlier this week, he pointed out something which I think was a good point. He was like, but we're not perfect. Like, we have so many things we should improve on. And I think that's exactly the point. Like, we're still learning. We have some best practices, and we constantly kind of want to improve on as we go. So this is by no means like the way we think, things are perfect. Like, transparency is one of our core kind of values at Cockroach Labs. So this kind of falls into that category of like, here are the things we're still learning and evolving. Cool. So should we start with some introductions? Jordan, Joel?
Yeah, sure. So I'm Jordan Lewis. I'm an engineering manager here at Cockroach Labs. I work on a couple of the different SQL teams that we have at the company. The database has it's a SQL database, and SQL, to implement it, there's lots of different moving parts. I'm a manager for the team that does the SQL execution part of things. So that's kind of the team that takes the instructions from a query plan and executes those instructions. So for example, maybe the query plan involves a hash join and a distinct and a sort or something like that. The execution team is in charge of the operators and code that actually perform those distinct joins and sorts. I also work for the SQL schema team, which is sort of the team that's involved in the infrastructure that provides schema information for tables, for schemas, for databases, and kind of all of the stuff that goes on there about leasing schemas to make sure that you can have a schema change that's online, so we don't have to lock a table while we're editing the table, stuff like that. So yeah, that's kind of like my role right now. I've been at the company since 2016, and I guess I've been doing management for about 1.5 or 2 years, and before that I was a engineer working on a couple of different teams. Did some work on the SQL team, did some work on another team, and so yeah, that's kind of my my introduction.
And you have a sweet setup that's perfect for a webinar. You look very professional.
Thank you.
Do you want to put in a plug for your Twitch videos? I feel like that's
yeah, sure. Okay. So I've been doing a bit of an experiment. Also, I guess I started it before COVID, but since COVID, it's been easy to keep it up, which is I've been doing a little bit of live coding on the database on Twitch, which is a pretty fun thing. So every Friday I will spend a couple of hours doing kind of some coding project about the database, whether I think most recently I've been looking at partial indexes in the database, which is kind of a neat indexing feature, but you can check that out. I have a handle called Large Data Bank. I'll stick a link into the chat in case you guys feel like checking it out.
Nice.
But yeah, there's my plug. Thanks, Lakshmi, for enabling that.
Joel, all you.
Yeah, so I'm Joel. I'm a site reliability engineer at Cockroach Labs. So I work on the cloud team. And so I started about just over a year ago when the cloud team was really like kicking off and going into high gear. And so a site reliability engineer at Cockroach Labs is really, in a way, like it is still a development role. We handle taking requests for cluster creations from the front end and actually interfacing with different cloud providers like AWS and GCP to spin up all of the necessary infrastructure like VMs, load balancers, and whatnot to run a Cockroach DB database for our customers. And so it's not, but we also manage like the infrastructure for the control plane of Cockroach Cloud. So when people log into our web console, we have several different services that are running behind the scenes that we need to ensure are highly available.
Do you want to speak a little bit about kind of your career trajectory before and what you brought you?
Sure. So once I graduated from school, I joined this small startup that was about like 5 engineers. And I was just a software developer at the time, but this company like grew like 400% in a year. And so there was like a lot of responsibility to just take on like all these new aspects of the company as we grew. And so I found myself really interested in working with like different cloud providers, particularly for this company, it was AWS. And so I sort of worked more and more with like provisioning servers and like understanding like how different cloud providers work. And that kind of got me interested in working in site reliability.
Nice. I guess I didn't introduce myself. I forgot to early on. My name is Lakshmi. I'm the general manager for Cockroach Cloud, but I'm part of the product management organization that kind of reports up to our chief product officer. So I work on various parts of Cockroach Cloud, including kind of the cluster lifecycle, some go-to-market pricing, so a little bit of everything, but fundamentally part of the product management org. Cool. So we kind of touched on this a little bit, but I'm curious to hear at a high level, what do site reliability engineers do at Cockroach Labs? And then kind of what do software engineers do broadly, and how you see kind of some of that roles different as we have it today? I don't know who wants to go first.
Sure. So yeah, I sort of touched on it, but we have a website where people will log in and they will like create requests such as like for creating clusters or for managing their existing clusters. And so we receive these requests via gRPC messages into our backend service. And then site reliability engineers have written all of the code that actually takes these requests and performs operations against different cloud providers, such as spinning up more virtual machines for a database or creating new databases, changing firewall rules for our databases. And so a lot of our time is spent developing new features for that. So for instance, I recently implemented VPC peering for our GCP clusters, which was a major request from many of our customers. And then we also have like a bunch of tooling like involving like Terraform or Pulumi to spin up like our infrastructure for actually managing like the control planes to ensure that our website is always available and serving requests. We also try and monitor the health of our clusters by developing like this black box tooling, and then writing like different Prometheus rules for alerting if something is going wrong for our clusters, and constantly trying to refine what these alerts look like. And then when we do get a page, then we have to actually like look into what is going wrong with the cluster and work with different engineers from across the company to try and diagnose the problem and come up with solutions for it.
And you're on call, right? I know that's kind of implied.
Yes, that is. So
it's still part of the role.
I was actually going to get to that a bit later, but
okay.
Part of being a site reliability engineer is that you do take on-call shifts. So right now at Cockroach Labs, we have a 1-week on-call rotation amongst all of the SREs. And so for 1 week at a time, we will be on call and receive any pages that come in relating to like, oh, this cluster is having problems, or a control plane went down, or anything else.
Yeah, sounds good. Jordan, you want to go next?
Yeah, well, Christian from the chat was asking what we were using for monitoring. Do you want to talk about that for a second, just to keep it interactive?
Yeah, sorry, I didn't see the chat. So we currently use Prometheus for monitoring our clusters. So each of our CockroachDB nodes has a HTTP endpoint where it just spits out a bunch of time series metrics that are being regularly updated. And then Prometheus will, every 10 seconds, scrape these metrics endpoint, download all of this data, and then compute it into time series storage. It'll store this data as time series and allows us to write rules to alert on it. And then for the control plane itself, we also have started using Datadog to handle like receiving all of the logs from our different microservices. And so for most of our cluster alerting, it's done with Prometheus and Alert Manager, but then we've used Datadog on the side.
Do you do alerts in Datadog as well, out of curiosity?
For the control plane, we do, yeah. So we have some alerts that are based off of metrics, such as like, an example would be if a particular job in the control plane is failing, some metric will be alerted and we will receive alerts from that. We also have some alerts set up based off of certain log lines being emitted. And another thing is we started using Datadog synthetics to track like if we can't log into a website. So the synthetics test will like every minute or so make a login request to a website, verify that we log in and that we see the information on a website that we expect to see.
How does it work having both Prometheus and Datadog? Are you guys happy with that? Is it something that, just curious.
So I think that Datadog is definitely a much nicer interface for writing alerts, and I'd love to use it everywhere, but it is a very expensive option, and it's hard to sort of use it for clusters when they have like per host costs. So every time we'd spin up a new instance for one of our customers, we would have to pay Datadog more money, and it just doesn't scale very well. So by using Prometheus for clusters, it saves us a lot of money over using Datadog. But for something like a website itself, which only has a set number of instances, that's a much more manageable cost, and it allows us to do things like this login test, which it's not really the sort of thing that Prometheus could do.
Cool. Looks like somebody's asking about CDC support as well. I think I'm not a complete expert in our CDC support. So I would say that one thing I would actually like to quickly plug for questions like this is actually our community Slack channel. I'm not sure if you guys have joined that one, but you should definitely join that. And somebody will definitely be able to answer kind of CDC questions in that Slack channel if you feel like it. So I will post a link to that in a little bit.
Cool. Jordan, I was wondering how you saw kind of the role of people on your team, like different software engineers on your team, differ or similar to the SRE role that Joel described.
Yeah, sure. So I guess Joel was sort of talking about how there's kind of two big functions of an SRE at the company. There's building things and also monitoring and paying attention to how the things are running in production. I think on the software engineering side, we have somewhat of a similar split. I think maybe for us on the software engineer side, I feel that there's kind of three big things that we try to pay attention to. We're talking about building the database in the first place. So kind of thinking about how you can make the architecture correct of a distributed database. It's a kind of tricky problem. And we've been working on it for several years. I think, there's a lot of things to work on in a database. If you've ever tried to build one from scratch, there's just a ton of things that come up, turns out. So there's a lot of work there. There's also testing. Testing is incredibly hard to do perfectly for a database, because if you think about it, a database is like a totally generic piece of software. It's like a programming language that also has persistence. You have all of the problems of testing a programming language, which of course can do anything. A Turing-complete programming language, you can't really test all of the programs in a programming language. So you have to invent some ways to figure out, is your compiler correct? Is your program generating code that is doing the same thing that you think it's doing, that sort of thing. Very hard to test that. It's the same in a database. When you write a query in a database, the query can pretty much do anything. And the more complex the database SQL language is, and ours is getting more complex every day, more or less, the more things that you have to test. And lately we've spent a lot of time trying to think about, well, how can we use randomized testing techniques to kind of find some of these problems that it's just so hard to predict ahead of time. And we've had a lot of interesting luck there. We had a sort of interesting progression, I think, through randomized testing. A while ago, one of our team members made a program that just generates random queries using the syntax tree as a generator. So sort of, it kind of crawls through this, Yak grammar, if you're familiar with that, and generates syntactically valid queries that may or may not be semantically valid, and just runs those through the parser, runs those through the query executor to see if basically they crash the database. But this generator really had no idea whether the query that it was generating made that much sense. So over time, we got this to be a little bit more advanced. Like, this thing can read schemas of tables in the database and generate queries that actually might read or write some data. And we can maybe check to see whether those queries are not just not crashing, but also kind of doing the right thing. And another really cool thing that happened recently is that some external researchers, some database researchers have been using our database as a platform for some of their testing research. Since we are a source available database that you can just download and play with yourself, they can run their tools against it. And we've been very fortunate to be able to work with some of these people from Zurich and somewhere else. Anyway, this project called Apollo. Anyway, very cool stuff there. So testing, right? We spend a lot of time testing. We spend a lot of time building. And then that last part is really, how do we support the production instances of Cockroach DB that are out there, both in our on-prem deployments and also in our cloud product that Joel is working on. So, the summary there is that you can just ask us to host your cluster, right? That's the simple way to say it. Go to Cockroach Cloud, say, I would like a Cockroach cluster, make it for me and monitor it and make sure it doesn't crash. So how can we make sure that on the database side, we're supporting the SREs when issues come up that are pretty deep into the internals? So for that, I mean, you heard that Joel said that they've got an on-call rotation. And on the database side, we also have a couple of different tiers of on-call for this as well, just both to support our on-prem customers and those cloud databases. And for that, it's sort of like, hey, we have how do we spread out the load, right? So we have kind of a big rotation for everybody that is also a weekly one. And if something goes wrong that they don't understand, it's not in their product area, say something, right? I mentioned CDC, like say I was on call and some problem came up with CDC, which I, to be honest, just haven't worked on. I can actually ask the rotation for that part of the component, hey, who's on call for that rotation? So it's sort of like a level 1, level 2 kind of thing. Yeah, hey, well, that was a rambling summary, but maybe that was a helpful overview. The DB engineering side of the fence.
That's great. I think Christian has a follow-up question, like what operational responsibilities do you have in your dev teams? I guess that's Jordan, probably on your team. You kind of touched on it a little bit, but are there any other operational responsibilities?
Yeah, I mean, I think it's really just about, we have to make sure that we're paying attention and being responsive. That's I feel like that's the thing, right? It's like, it's very easy to not want to be responsive if you're working on something really hard, you're deep in the optimizer. But if something comes up, like, hey, we're a company with customers and the customer just has to come first. So if something happens, it's very important that we pay attention and we get on top of things quickly. We use OpsGenie. I don't know if you guys are familiar with that. OpsGenie, it's like one of these sort of alerting, human alerting tools as opposed to the Prometheus, machine alerting tools. It pings your phone. And if you don't pick up, maybe it'll escalate to your boss and you'll get in trouble, something like that. So we've got some systems like that in place. Are all devs on rotation? Yes. Well, sort of. I mean, we had this L1 thing that we have a subset of people on this rotation so that if they want to actually eventually rotate off the rotation, they can do that. And we'll have a pool of backups. But on the individual dev teams, so it's like that level 2 support that I sort of mentioned. Yes, everybody's going to be on that. And so if something does have to escalate to that level 2, that more expert support, everybody who's been at the company for at least a few months is going to be on that rotation.
I see there's another question. Are there any strategies you find successful for on-call production health responsibilities when you have a very small staff of engineers? So yeah, I can start off with that. So one thing that we really try and hold to on the SRE side is to make sure that the amount of operational workload that we're doing is less than 50% of our overall work. And so we typically will have the on-call SRE handle like all of the ops work, and they will pull in other SREs if it's needed. But if there's no actual issues happening with any of our clusters or control plane at the moment, they will dedicate that week to actually improving the on-call experience for future SREs. And so things like that could be like developing automation to perform tasks that we would previously be performing like manually, so that we can just run operations much quicker and yes, just invest less human effort into the on-call rotation. We also, if we are dealing with some difficult issue that's spreading over a longer period of time, we have a weekly handoff meeting where all of the SREs get together, and the person who was on call will go through each of the items that is paged over the past week and what they did to handle it, and any ongoing issues are talked about with the whole team, and then the next engineer that's going on call will like pick up from there. I don't know if there's anything similar like on the software side, Jordan.
I think that that's probably more of a mature development of the idea than we have. I think I sort of tried to summarize it before with the two rotations.
So I'm curious, kind of along the same thread of like the central tenets that you have. I feel like there's a very strong culture of 4 or 5 key philosophies that you all have, and maybe it's more common in the industry. So it's not. I'm not saying it's specific to Cockroach Labs, but can you speak a little bit about that, like postmortems, and you kind of touched on the 50% ops load versus kind of development work. Yeah.
Yes. So yeah, definitely like trying to keep the ops load below 50%. We don't want to be just an ops team. We want to be an actual development team that's progressing on providing new features to the cloud environment. And so if we find that we are repeatedly performing the same operations, we try and write automation to handle those operations for us. But even before we get to the level of writing automation, if we performed an operation like once or twice, we will write a playbook on how to perform it, so that the next on-call engineer doesn't have to reinvent all of the steps from scratch. They will have like a very like step-by-step guide on what to do, which reduces the amount of errors that can be made. It also just allows us to work much quicker. Also, another tenet, I guess, is blameless postmortems. If we do have an issue, sometimes it could have been caused by something that one of us did that was probably not the correct action, but we don't want to like be passing blame around. We're all trying to learn and just improve. So yeah, we like not assigning blame, just discussing what went wrong and what we can do like as a whole engineering organization to prevent it from reoccurring.
Yeah, I love our postmortem culture. I was looking yesterday actually for another postmortem from last week in our internal wiki, and there's this like, whatever, 10, 15 or so from the last couple of months, which is actually not that bad, of the date and the exact event. And
yeah, like
and I love
at this time, such an event occurred. At this time, we took such an action.
Yeah, that's pretty great, without names necessarily. There's a question around TLA that I think that's for Jordan, if you want to speak to that. Have you ever looked at formal methods like TLA plus?
Yeah, good question. I think we have made some sort of TLA plus model for part of the core transaction protocol. I think it's pretty sophisticated. Some people were asking me if we were going to use TLA plus in SQL, and I said, maybe. If I had anybody on my team who understood that particularly well, maybe. But I think I don't understand TLA plus that well. It seems really cool, and I think it's really good for verifying sort of those like really core, transaction protocol algorithms. And I think we've done that. I think it's on our GitHub if you want to check it out. But to be honest, I don't know too much about it.
That's fair. Alicia was asking about playbooks, since Joel talked a little bit about playbooks. Can you talk about playbooks versus building systems that automatically recover or don't break in the first place? And like, what are the trade-offs between playbooks that humans write and read versus, I guess, kind of software development and automation?
I think playbooks are sort of like an intermediate step. Like you definitely want to build systems that can automatically recover or just don't break in the first place, but that takes time. And when you're dealing with an issue that needs to be solved like immediately, you don't have time to like develop a perfect solution. And so playbooks can sort of hold you over in the meantime.
And I feel like one of the things we talk about around the playbooks is having a single playbook, right? Because one thing we didn't mention is we also have a customer support team that is kind of the frontline team that interacts directly with customers. So if you are a production customer of ours and you open a P1 ticket or a Zendesk ticket, customer support is kind of the first line of defense. And they kind of have their own playbooks, but there's also this interaction between the support team and the SRE team, which is interesting.
Yeah, so I think like that's definitely one area that we could improve on at Cockroach Labs, is sort of unifying the playbooks that are used between the SRE team and the customer support team. The customer support team has a lot of playbooks that help with debugging when a Cockroach DB cluster is going wrong, whereas a lot of the SRE playbooks right now are focused more on what happens if something goes wrong with the infrastructure of like a node dying in AWS or needing to like change some parameter in a cluster. And so I think if we can unify these playbooks, we would have a much better experience. And that's something that we are working on.
Yeah, so something that I would add is that to me, it's not a trade-off. I think you need both. I think Cockroach DB is an increasingly mature system that is both complex, but also resilient to failures, right? You can, let's say you have a bug. Let's say I wrote a bug and it causes one of the servers to crash. We're lucky enough that, you know, we've thought about the architecture of this thing pretty carefully, and we've made sure that if something crashes, it's not going to really break the database in a sense. A node will go down and something will restart it. And everything's just going to be fine, you know, sort of from the perspective of your data integrity and you know, the actual production load on the database. But that being said, you know, you still sort of need to do something, presumably, once you've figured out that there is a bug, or, you know, maybe Joel's monitoring systems notice that something's restarting every couple of minutes, something like that. And you need a playbook for that, right? It's like, I can't guarantee that none of my engineers are going to write bugs, and nobody can guarantee that. Everybody writes bugs. That's just the nature of software. So it's really a matter of how do you have both, right? How do you have monitoring in place, automated systems to recover, but also how do you train, you know, your support and engineering staff to notice these things and be able to quickly resolve them when they come up?
Yeah, and that's a good point, because like some playbooks are focused on actually resolving an issue, whereas other playbooks are focused on just how do you get the information that you need in order to investigate the root cause of an issue that's occurring. Mm-hmm.
I wanted to also circle back to Renee's second question about randomized testing, just because it's a particular passion of mine. It's actually bearing so much fruit. Like this stuff is, it's just amazing. And I think fuzzing, it's kind of similar to fuzzing. It's sort of like semantic fuzzing. I think normally with fuzzing, it's like you have some really, really simple, you know, maybe it's like a parser or a protocol reader thing on the internet, and it's like reading these bytes and trying not to crash or something like that. So fuzzing is about generating like little byte strings that try to explore different paths of a program. With SQL, it's like you have to be a little bit smarter because to make a semantically valid SQL query, you have to like know a ton of stuff about what's in the database, you know, how the SQL grammar works and how things can really fit together. But once you have those stuff as a basis, and you have a program that can kind of explore this tree of possible queries, you can generate these like insane queries that humans would never really think to write, and yet they have real bugs inside. You know, if you pay attention and yeah. What am I trying to say? I'm trying to say that like the more complex you make these queries, the more likely it is that you'll find some edge case that probably you just didn't notice when you're unit testing in the first place. And it's, by the way, it's a similar technique that people use in programming languages in general. Like I was saying earlier, it's programming languages they're very expressive. They let you do almost anything. And trying to enumerate all of the things that a user might try in a programming language is impossible. So this randomized testing thing, it really does find a lot of issues. We're very happy with it, and we're gonna keep doing more of it. I hope.
Also, for a database, a lot of SQL, I imagine, is generated by ORMs and not even by humans. So that probably produces some very funky queries as well, right?
Yes, that is a great point. ORMs, I have a love-hate relationship with ORMs. I think that they make a lot of developer lives easier. And I think when I was programming against databases and not working on a database, I liked using an ORM because it really was so simple to use. But on the other hand, as a database developer, these things just generate really crazy queries and really things that are generally sort of just difficult to optimize, difficult to understand. And it makes sense. It's hard to build software. It's hard to make abstractions. And as a database, you just have to handle it. It's just not that easy.
We now have a team that's kind of dedicated to that, right?
Yes.
Yeah.
So we do have a team that's kind of dedicated to building support for these ORMs and drivers on the client side. And that's really great. I think that's working nicely. And that's going to mean that we have more compatible tools, easier interoperability with CockroachDB from the developer perspective. That being said, it doesn't necessarily mean that the queries that these ORMs are going to generate are simpler. It just means that from the developer perspective, they can get started quickly. I'm really excited about that initiative, though.
Nice.
A lot of snark in the chat about ORMs.
This is a hot topic, ORMs. Wow, there's a lot of questions. I don't know if other people can see these chats. Is this just for panelists? That's too bad. There's some really good comments here. I think these are just to the panelists. All right, let's see. I'm gonna scroll through some of these questions. Joel, Jordan, feel free to jump in if there's any that you want to address. So Alicia had a question around postmortems. We kind of touched on that. Playbooks. Yeah, Renee was kind of just following up on the blameless postmortems as, like he's a big fan, and specifically the long-term fix gets lost in the constant journey of the now. So what is your experience or recommendation for other teams that may be experiencing this?
Yeah, I think that's a valid problem, and one that we also find, we also struggle with that. I don't know what the best recommendation we have because we're still trying to figure it out ourselves. We definitely try and file GitHub issues for any issues that do arise, and just that weekly meeting where we all get together and actually go through all of the issues that have occurred. Those are both very helpful for keeping issues that are important on the forefront of everybody's mind. But we have had some long-term fixes slip through the cracks just because we've moved on and focused on the tyranny of the now. So it's still an ongoing problem for us.
For me, it just comes down to prioritization. If you can have a system that lets you see easily the work that you have said that you're going to want to do, or maybe your roadmap work intermingled with things that you found in a postmortem. And it's just so important. You just have to use a consistent filing system. I learned this from some sort of note-taking seminar once, but it's just so true across even engineering as well. It's if you have this one place where you're using for both your features and your bugs and your this and your that, you're just going to forget stuff. And one of the hardest things is cutting stuff, right? It's let's say you have this big roadmap, all of a sudden something goes wrong and you have a postmortem. It's oh no, we really messed up and we have to fix this, that, or the other. And this architecture is wrong. You're just going to have to come to terms with the fact that you're going to have to cut some stuff from your roadmap. And that's just such a hard thing for people to wrap their heads around. Even for me, you don't want to cut the stuff that you put on your roadmap. You made promises, but sometimes, you have to make those hard decisions.
What's your philosophy on leaving some slack in your roadmap or milestone to allow for these kinds of scenarios, or even tech debt, or just things that come up that you didn't, do you have a magic kind of 20% time, 10% time?
My philosophy is that you should do it.
All right.
So I don't have a number, but we definitely, every quarter, we leave a fair bit of time to allow for just either operational improvements or for just digging into issues that arise and then fixing them. There's no number, but it's a fairly substantial amount of the time that we allocate.
Yeah, on the product management side, we always say, if you're going to build a feature, in addition to knowing what the problem you're solving, why, all of that stuff, you also need to be able to know what what you're willing to trade off or give up to build this one thing. And it kind of goes along with what Jordan was saying. Like, prioritization is hard, but like you should have some opinion of like, okay, if we do this, here are the 5 things we're probably not gonna be able to do, and that's the trade-off. Trade-offs are hard, right? But yeah. Let's see. What other questions? There was something around chaos engineering and if we use chaos engineering testing tools. I don't know if Christian had a question around that.
Yeah, so I can speak to that a little bit. We have a couple of different techniques that we've been using for this kind of testing. We have a framework called Roach Test, very charming name, that lets you kind of spin up these sort of big integration testing scenarios using real nodes, real VMs, and you can make them different sizes. You can do anything. You can kill them in the middle. So what we like to do is make some tests that are running a certain kind of load that we can then vary sort of these meta parameters, like, are you killing a node? Are you changing the latency between nodes? There's this thing called ToxyProxy. Maybe you've heard of it. If you've looked at the chaos engineering stuff, it's pretty cool. It's kind of like this network filter thing that you can stick on a machine that simulates problems like network partitions or latency issues. And so we've definitely played around with adding these things to our nightly tests. We have like a bunch of these that get run every single night. It spins up like huge numbers of VMs and runs these scenarios and tries to check that things didn't go too wrong. I think it's pretty good. I think orchestrating these things is generally kind of hard. I think the biggest struggle that we've had with it isn't really making sure that things are working. It's really making sure that we can tell whether things are working or not. Because when you're testing these scenarios with real VMs, and there's many of them, and you're trying to do it in a totally automated way so that, it's not like Prometheus where something alerts if something kind of goes wrong, and then there's a human in the loop. It has to be just like completely automated. Did you succeed this test or not? And it's like, you're going to try to define some bands around the latency and the throughput. And if you like get the bands kind of wrong and something goes off, then it's like, well, somebody has to investigate, but maybe since we have 100 of these tests, like, does anybody remember like what this thing is actually trying to accomplish? So I think there's challenges with chaos engineering in an automated way like that. I think a lot of companies, what they'd like to do is do chaos engineering on their real-time systems as well, or their production systems. I don't know if we've really played around with that yet. Joel, do you know?
Not really right now. Right now, each of our clusters is very single tenant, and so it's difficult to sort of play around with this sort of chaos engineering without having a negative effect on like a particular customer. We are sort of investigating more multi-tenant approaches to running Cockroach Cloud, where we could perhaps amortize the cost of chaos engineering tests. We also have performed like some sort of manual chaos testing against internal clusters. But one sort of project that I would like to see us work on in the next few months is actually hooking up the nightly builds of CRDB into Cockroach Cloud, and that might enable us to then perform chaos engineering tests against them and move some of the even Roach Prod infrastructure into the cloud product.
I don't know if people know what Roach Prod is. You want
to? Roach Prod is just the testing infrastructure that Jordan had mentioned that can spin up VMs and play around with IP tables and killing nodes.
Nice. I kind of had a topic around this, and I think somebody also asked, what is the kind of interaction between the database engineers and our site reliability? How often, how, and maybe an example or two of something that we collaborated on in the past. Anytime there's one of these postmortems, we tend to definitely do that.
Yeah, so one example, I guess, of an issue that we have found in Cockroach Cloud is when we would take backups, we would read from a certain system table in order to determine when the most recent backup had been taken and if we need to take another one. And when we read from this table, it ended up loading all of the data from this table into memory and not accounting for that in the memory tracker. So we could end up out of memory one of our nodes. And so there's been a lot of back and forth with the database engineers to try and add additional memory tracking on this table so that we can take backups without crashing. Jordan, you want to talk about that a bit?
Yeah, I think this is a great example of how the kind of DB as a service division of the company has really enhanced our ability to make a great database. I think one thing that was hard before we launched Cockroach Cloud is that we really only had our own tests and on-prem deployments to use as source of finding problems or finding enhancement areas for the database. You know, if you're writing tests for something, you probably already know why it's broken in a sense. It's the things that you aren't writing tests for that are scary. And I think when you have on-prem customers, maybe they'll report a problem, but it'll be really hard to reproduce. A lot of the times people don't want you like poking around in their internals to look at stuff. So of course you can't really do that, and it can be kind of hard. But with the Cockroach Cloud division, you know, we have a huge new source of kind of production use cases that we can look at more easily. That's been really exciting. So this example that Joel was talking about with this sort of job tracking business was essentially caused by, well, there's a lot of technical details. Let's see, I'm trying to think about how I should phrase this. I guess in this particular instance, it's kind of like we didn't think about what would happen if somebody made a ton of jobs in the database all at once. Seems pretty obvious, but you know, sometimes you just don't think of things. And it turns out that what the database was doing inside, when you would ask for, give me all the jobs that are currently ongoing in the system, it would actually read them all into memory before giving them back to the user. And of course, like for actual data, like we don't do this. For like your user data, we have like a whole system that's pretty complex about streaming the data, and we account for the memory really carefully. One kind of frustrating thing about writing this database in Go, which we decided to do if you're familiar with Google's Go programming language, is that the way that you can track, you know, it's a garbage collected language, and tracking the memory that you allocated in the database or in this programming language is just not that easy. It's not that ergonomic. Don't know if it was really designed to do this kind of thing, but we've kind of made it work with a bunch of manual things. The thing is, like when it comes to this jobs thing, we just didn't really think of adding this memory accounting to that because we just didn't really come up. Turns out people are going to make a lot of jobs. People are going to want to back up their database every hour, whatever. And when it came time for this thing to actually get read, you know, we loaded it all into memory. Maybe there's other stuff going on in the cluster, we blew up. So we were excited. You know, we saw this report. Joel was probably not that excited, but I was really excited. I said, oh man, this is something that's totally broken. Thank you so much for reporting it. Like, we're going to try to fix it. Yeah. So I don't know. There's more details like about the release cycle and stuff like that, but I think that's kind of the top level summary. We love the Cockroach Cloud team. It's just really such a blessing to have them.
Yeah, I think it's easy to have blind spots in testing. Like, there's also been blind spots with like, well, if all of our tests run with a certain root user, and then when you try and perform this one particular operation using a non-root user, suddenly a node will crash, and it was just nobody considered those exact interactions. And then when you're running in the cloud with like many different customers, you suddenly can find these different cases and realize, oh yeah, we went testing for that particular case before.
Exactly. Christian was asking, I was saying VMs. I think I probably just meant, I don't know, what do you call it? When it's a VM in Kubernetes, a pod?
Well, it's still VMs underneath the covers. They are, like, I guess like the Kubernetes language would be like a node, but.
Yeah.
With this question, which is interesting, from Omkar, do you have any advice on building production-grade software mentality while still in school, and how to get ready for an SRE role in the future? SRE or software role, I think. Yeah. Probably for you, Joel, because you were saying you didn't start off as an SRE, right?
Mm-hmm. I mean, I think like one of the most helpful things you can do to prepare for like post school is just to try and get an internship. Like, I found that I really appreciate a lot of what I learned in school, but it didn't teach me the same skills that I needed to work like in the industry. But having like a couple of internships before I graduated, that taught me so much about like the sort of work I'd be doing like post graduation. And there are internships available for working like on SRE or other infrastructure focused teams.
If you had someone from recording this, would be the plug for for that. I believe we are still hiring for SRAs on the team, but anyway, I won't mess that up. It's on the careers page if you're interested in that. And kind of related to that, Jared had a question around if you have any best practices or approach to training and getting new engineers to the company ready to go on call and handle real production issues. I think, Jordan, you've probably worked with new hires who go on call, right?
Yeah, I can take this one. I think it's pretty tough, I think, at first, because like I've been sort of alluding to, the database is pretty complicated and it can be really overwhelming and scary if you're somebody who's just joined the company and you're expected to go on call. It's like, well, I don't know how this thing works yet. It might take months, to really understand even just your area. And so we've played around with this sort of buddy system. I don't actually have this on my team yet. I kind of want to have it on my team. I think one of the other teams does. The way it works is that if you're a newer person, you can kind of be a secondary on call or something like that, or maybe like a buddy on call. And the way it works is that the person, when somebody gets paged, you're going to both get paged. And when you both get paged, the idea is that you're going to jump on a call or a hangout or a Slack with the person who's the more experienced on call, and you're going to kind of debug it together. And hopefully, I think that's a pretty good kind of way of learning, along with your normal ramping up into the code base, trying to do your projects, trying to figure out how stuff is working. I like that idea.
That's something that we've used on the SRE team as well. We don't start off people on call right away. Like they start going into the on-call rotation after 3 months. And then we will typically double up the on-call rotations for them. So they're paired up with an experienced engineer. Also, just having clear playbooks, like I mentioned before, is really useful because they might know at a high level, oh, I need to collect the logs for this node, but how do I actually do that?
Yeah,
that's useful. And just going through like practice runs, like on test clusters, like causing something to go wrong on them, and then having like the new hire like try and actually debug the issue.
Yeah, that's kind of fun, like a live kind of capture the flag scenario for your on call. Have you guys actually done that?
We've done it a couple times. Yeah,
that's awesome.
It's fun, not just for new hires, but
right. I kind of go ahead.
I was going to say it's the equivalent of the sales team. On the sales team, after you work for, I don't know, X months, 2 months, 3 months, before they put you in front of a customer, you have to go through like a certification pass where you actually know what you're talking about. I feel like this is the SRA equivalent of that. Go ahead, Jordan.
I was going to say, on the other hand, I think that sometimes there's no better way to learn something than to be kind of thrown into the deep end, so to speak. The first time that you're not going to be on that secondary, you're going to be primary on call and somebody calls you with a production issue. It's going to be scary, but you're probably going to learn a lot. And you're always going to have some teammate available in case you can't figure it out. You can pay somebody else. You can get them up. But being the person there, I mean, that's going to be a scary moment, but it's going to be a big learning moment. And I think there's definitely something to it. At a certain point, you do have to sort of step off the cliff. And when you do it, things are going to happen for you.
Hence the blameless postmortems.
Right.
Chris is asking if there's any competition between the different teams, between the different dev teams.
I don't know if we've done that just yet.
Yeah. Well, this has been fun, guys. I think this was 45 minutes. I'm not entirely sure. Maybe we're over time. Oh, well, it was fun. Any other last minute topics or things you wanted to chat about that we didn't cover?
No.
Are you streaming tomorrow, Jordan?
Yes, I will be streaming tomorrow. You guys should check it out. Inflate my viewer count above, 5 where it normally is. If you would, that'd be awesome.
What is it? 2 p.m. Eastern? What time is it at?
It's 3 p.m. Eastern. Yeah, I'll yeah, it should be fun. Thanks for watching, everybody, as well. I hope it was good. Hope it was useful. It was nice taking your questions. That was really fun.
Yes, thank you.
Yeah, cool. Thanks, everyone.
All right.
See you all soon. Bye.
Have a great day. Bye-bye.